think on the first slide, we just kind of break down the current options that you have. I'm not familiar with most of these. But it feels like there's several options, but then there's also a ton of stuff out in journals and master's recipes and hobbyists, and that's definitely true. I found so much documentation on this. But then, second slide is like just trying to convey the concepts for the FEC API, and you can have multiple implementations. Deployments can be used hierarchically. Applications can use the interface directly, and as long as the class is inheriting from the base classes, then the FEC API continues to grow. And that was one just comment that I wanted to make. As he was explaining to us, so like we were creating these algorithms in Python, and then we were ready to move them over, and basically all I have to do is inherit from, he's got a generic encoder and a generic decoder class, and we just inherit from those. And there's 3 virtual functions that you need to define. Generic work, get input size, and get output size. And so for the decoder, or for the encoder, the bulk of the work happens in the work function, like you would expect. But then you can assume that when you set the input size and the output size, that you have the bits, or the data in the input buffer, the room in the output buffer, and you just need to write in the work function what to do, and everything else is handled by what he's written in the API. He's got the default virtual functions on the right side, and a lot of those I didn't even need to mess with for my particular algorithm, but those are set up as well. Says defaults, there's no frame overlap, soft float inputs, unpack bit output, fixed frame sizes, simulated frame, and no buffered input. And intentions, the inheritance should be easy, and the interface should have as little impact as possible on the code design. So the CC decoder is there. I'm sorry, I don't know how to interpret this diagram on the right. Anyone wants to speak to it?
What is the...
But the features, 8-bit fixed point implementation using a 16-way vectorization. Rate is a half, and rate is 7. Parameter type, I think that you can parameterize. And like I noticed, if you go in and you look at the CC decoder that he's written, a lot of it is pretty sophisticated. So like if you wanted to start using the API, you might do some sophisticated things in here that, like for me, necessarily I didn't have to use. Like the tail biting and the truncated nodes. But he mentions intentions. Make the spiral decoder immediately useful to GNURADIO. Provide an example using all of the FEC API aspects. Yeah, that's true. So others, the Reed Solomon. I'm not familiar with these guys on the left, but then, like, of course, like I mentioned, we were using it for load density theory check node implementation. So the basic deployment, fixed rate decimation history with node 0 fill, requires SVRT interface object, word decodes as many frames as possible, supports destructive and non-destructive nodes, oddities, it does not inherit from the sync decimator, does not use set history. So intentions to promote code in GNURADIO without having to re-implement basic GNU Radio inheritance materials. For the extended decoder interface, I guess I should mention this, for like the extended decoder interface, from what I understand, this isn't things that you would have to mess with necessarily, it's already done. There's a GRC variable to create a list of generic decoder objects, a standard decoder interface, type conversion based on interface virtual functions, threading via instantiation of FEC decoder blocks, and access common utilities. And attention, provide a 90% solution for threading, type converting, and softbit manipulation. Now this slide really didn't understand. Understand what he was trying to say here?
Sure. So like the standard decoder interface that you just saw is like a streaming interface, so that makes sense for but it's streaming mixed with. So basically either for continuous convolutional codes or for framed codes with Bitcoin where it just jumps through on that block size. The idea of this tagged FEC decoder is if you look at like the stuff that Mark is doing with LPM modem, you've got these tagged stream item blocks, and at some point you have a tagged stream item block fix. And then this tagged FEC decoder, the idea is that it takes in a variable length FEC code and does like a tail biting code on it, or something of that variety. It's a variable block size. Okay, and so this pool resource deployment, I know I'm not talking about event stream this year, but Nick and I have built lots of new event stream, and the idea of this pool resource is if you have something that is going to allocate arbitrary number of decoders, and it's very data dependent, like which code rate you're going to see on the air. We've got this template called a pool resource, and it basically allocates them on demand as needed. And so he's just built this pool decoder wrapper around it that helps you allocate them as needed.
So he wrote a bit error rate comparison development app, or basically to generate a VPR for NGRC, which is really nice. I hadn't had a chance to look at my stuff in this talk, but the idea is that the framework is there, so once you have an encoder, a decoder written, plug in and use this to visualize it on NGRC. So just in case you can't read, this is just a plot of it, and it says the blue is unpunctured and the red is punctured. So this is, I guess, specifically for this convolutional decoder. Like the terms punctured and unpunctured, that's pretty specific, I think, to that algorithm. But he highlights there's real-time visual feedback, there's settings for the number of errors until the result blocks. There's a minimum discoverable VPR. It cycles through 35 distinct line styles, curves which are named from the GRC object parameter. So it's really slim. Other features, FEC interleave and I used to say that de-interleave, core, puncture, and reinflate. Primary benefit for n output streams is size m items each. FEC interleave and FEC de-interleave can execute work with only m rather than n times m items available. So minimum buffer size will be M rather than N times M. Breaks forecast, only one string, not all, might inserts. Common attractions, tag string, ordinary deployment, tag string, resource pool deployment, tag string base class, measurement application. That's it. He's pretty responsive. If you have questions, he should for sure be the one to answer them.
I have a question. I know you talked about it. Is your editorial stuff in GNURADIO? Are you still trying to?
I'm in the process of it. I tried to, what he suggested, which I thought was a great idea, was to use pylons to try to build my stuff within the FEC API. So I had some issues there. I was trying to get lazy/crafty. So no, to answer your question, not yet. But both Manu and I, that's what we're trying to do.
How smooth is it? Is FEC API ready for this kind of stuff?
Well, the reason this kind of threw me is there's so much there that I didn't even realize was there. For what I wanted to do, once he explained it, yeah, I got it. You just inherit from the certain generic classes, and you define certain functions. It seems really straightforward. And then to not have to worry about all the back-end stuff to put in the GRC saves you a lot of trouble. But some of the other stuff, yeah, I hadn't even looked at.
You may not be able to answer, but did API does not for block codes that are not client-based.
Block codes that are not what?
Client-based. He had a slide in there that said that when we resolve, he said, the only work says implemented for like the Galileo routine. I don't think the API will work at all for anything that's not, or any of the block codes that are not a white Galileo that is white. So I think you're going to be stuck on your spec API other than some fixed space in your API. One of you look to me like there was a pretty big hole that everything in communication, everything is not like we work in this different Galileo, 6-bit, what do you tell me? Code signal. But it's a very hard thing to try and handle that process. I don't think that's true.
Yeah.
I think you can have any way to make sure that you get guidelines to use your language for it. It's just like the
Well, the problem is the API was a pain in the ass.
well, yeah, in streaming interface, you need to work on something that's right. But I think you don't really have to throw it into the
How you gonna represent 6-bit?
forget about the interface, so you have zeros, and you operate.
No, I understand that, but the API has to change and say, you're going to have to hand in symbols, repeat things in the API twice. They refer to this last sentence, something.
You can refactor the stuff that, and then you can do it in, so that you know there's only a certain percentage that's provide. I mean, that's how we do, we use the refactor function. Yeah, I have this very discussion with LinkedIn, like, forget my program, but I know that it's called this, and it would be future of it. So, I know the fact that it's called this, and we didn't write it, pretty close. Because, like, your phone goes on always falling to the base, right?
Yeah.
If that works.
Yeah, they never are.
So the resolvent code he's got in here, I think is GNU 56. Like, it's which I think is
Galileo.
like E6.
Yeah, and that's what fine.
Yeah, so I think he just hands it in as, you know, there's always a multiple of 8. You still got a fixed number of bits in and out. So that's really the only string here. So the idea of the resource pool is, say you have 8 threads that are just decoding random frames as they come in, and maybe there's 10 different convolutional codes that they could be, and you don't know beforehand and you don't want to pre-allocate them, and so it provides a pool of these things, and then provides a locking-free mechanism to acquire one of a specific type. And then there's actually a callback to a factory function that like produces that great coder. So we've used it for a lot of things, not just coders. I mean, it's basically just a log-free way that you pool your resources. We started using a lot. And it's all based on the boost log-free stuff.
Yes, favorite emphasize the possible different kinds of FPGA blocking and chat or
Yeah, that's all more detail.
anyway,
You can certainly wrap some sort of offload inside the kernel of one of these when you use a hardware encoder. Doesn't really
Thank you very much, Tracy. We're a little behind schedule, but up next is Matt Ennis to talk about the RF